Lesson 74, solving absolute value equations. The absolute value of a number, n, is the distance from n to 0 on a number line. Okay. A lot of times we make the mistake of thinking that absolute value means the opposite, and that is not true at all. It is always the distance from n to 0, whatever your number is, to 0. Okay. That's why absolute value is never a negative, because we can't have negative distances. So, for example, if I wanted to know the absolute value of -5 is here, 0 is here, that distance is 5 units. So that is an absolute value of 5. The same is true for 7. 0 is here, 7 is here, there are 7 units between, which gives me an absolute value of 7. So it says if the absolute value of x is equal to 5, then x equals 5 or x equals -5, because looking at our graph, I could have also had that it was 5 here, if I'm talking about 5 as my number inside the absolute value, and I have 1, 2, 3, 4, 5 units from 0. So it's 5 units in either direction, which means that x can be +5 or -5 inside the absolute value. It says, similarly, if I have x plus 2 equals 6, then x plus 2 has to be equal to 6 or -6, okay, because the absolute value, whatever's inside of here, can be the positive and be 6 units away, or it can be the negative and be 6 units away. This is key to what we're going to do today. So, on example 1, all it wants to know is the absolute value of x is equal to 4, so we want to know what's possible for x. So, that means I'm going to drop the absolute value bars, and I'm going to write it as x is equal to 4, and x is equal to, or x is equal to -4. Okay? This is how we're going to solve our equations. We're going to drop the absolute value bars once they're completely by themselves on one side of the equal sign, and then write it with the positive and the negative out here. Okay? So on B, we're going to drop the absolute value bars. So I have x minus 2 equals 10, or I could have x minus 2 equals a -10. I need to solve both. So if I want to get x by itself here, I'm going to add 2 to both sides. Cancels. So I get x is equal to 12. Or over here, I can add 2 to both sides again. And that would give me that x is equal to -8. That's my final answer. Same thing here. I can't drop the absolute value bars until it is completely by itself on one side of the equal sign. So this 3 is being multiplied by the absolute value of x. The opposite is going to be to divide by that 3. What I do to one side, we must always do to the other. 3's will cancel, which leaves me with the absolute value of x is equal to 9. I can drop the bars and say that x is equal to 9 or x is equal to -9. I would like for you to pause the video and try to do B on your own at this time. Okay? Remember, we have to get the absolute value bars completely by themselves first. Okay, so the way we're going to start this problem is by dividing by 5 on both sides to get the bars by themselves, because the 5 is being multiplied by this absolute value. So I divide by 5 on both sides. Leaves me with the absolute value of the quantity of x plus 3 has to be equal to 12. So I'm going to drop the bars because they're alone. So I have x plus 3 is equal to 12, or x plus 3 is equal to -12. Solve for x on both, so I'm going to subtract 3 from both sides. I get x is equal to 9, or if I subtract 3 over here, then I get x is equal to -15. Okay, on this example, we're doing the same thing. We still want to get the absolute value bars by themselves. In this case, we're adding 4 to it, so I need to move this. So to move it, I'm going to subtract it from both sides, which gives me that the absolute value of x plus 3 is equal to 0. And the only way that I can have a 0 out here is if I have a 0 in here. So whenever I do this, 0 doesn't ever have a positive or a negative, it's neutral. So it's just going to be that x plus 3 has to be equal to 0, so I subtract 3 from both sides, and I get that x has to be -3, okay? Because I can't make 0 a positive or a negative. Okay, on example B, we have a similar situation here. We want to get the absolute value bars by themselves, so I'm going to divide by 5 on both sides. So I get that the absolute value of -2 is equal, absolute value of -2 is equal to -1/5. The absolute value is equal to a negative. Can I have a negative for an absolute value? No, because I'm not going to have a negative distance. So this one has no solution. Alright. Last example here. So as a thermostat in a classroom is set at 21 degrees Celsius. The thermostat will turn on or off if the recorded temperature is plus or minus 1.2 degrees Celsius of this setting. What are the maximum and minimum temperatures for this classroom? Okay, so I know that the thermostat is set at 21 degrees Celsius, and it will kick on or off at plus or minus 1.2 degrees Celsius. Okay, so at plus or minus, that means that I could add 1.2 and it'll kick off, or I could subtract 1.2 and it'll kick on, whichever way, if it's heating or cooling, I guess. So if I add the 1.2, then I have 22.2 degrees Celsius, and if I subtract the 1.2, then I have to take you back to elementary school here, because that should have been a 0. So I have 19.8 degrees Celsius. So this would be my minimum temperature, and this is my maximum temperature. The temperature should stay between those two. And that is all I have for you today. I hope that you've taken good notes, and I will see you in class tomorrow. Have a good night.